Hey everyone, today we'll be going over graphs today. Particularly we will be focusing on recursive breadth first search for a weighted graph, and without any further hesitation, let's get started. And now we're going to perform breadth first search recursively. So the way we're going to go about this is that we always need to keep in mind and remember that recursion is really building upon a function inside of a function. So that means we're going to have two functions. Excuse me. We're going to have our helper function, and then we're going to have our function we actually call upon. So the way we're going to build our helper function will be the following. So void BFS recursive. This time, since breadth first search uses a queue, we're going to go queue int and queue with vector with boolean, and we're indicating what has been visited. Then we are going to see, in the case where if the queue is empty, that means we're just going to return nothing altogether because we have not added anything inside of the queue. And then we're going to initialize our first vertex to be at the front of the queue, since queues operate based on first in, first out. Then we're going to pop the queue accordingly, and we're going to output each vertex with their respective space that we have. Then we're going to have a for auto loop. For auto I equals adjacency v at the beginning, while I does not equal to the adjacency vector or adjacency list with the respective vertex at the very end. We're going to increment our index accordingly. Then, since we are dealing with weighted graph, we're going to have to use first. So if the following vertex has not been visited, because it's a Boolean condition, then we're going to have in the context as well for the respective edge of index first, indicating for the weight of the given edge. There we go. Then we will be pushing each index and the respective weighted edge to indicate that we have visited once we have already reached it. Then we're going to push it inside of our queue with I first is really just the edge. Then we will be doing this until we have reached the end of our adjacency list. So BFS recursive, yes. That means with queue, and then we will have visited as well. So we're using parameters inside of parameters to be able to run around until we actually reach to the end of our final queue. Then we're going to have our function that we actually call upon in our main function. So it's going to be void breadth first search recursive at the very start with int v indicated as a single vertex, and then we're going to have a vector of booleans to indicate what has been visited, and with our vertex that we have initialized at the very top right here, along with the vector list that we made for our adjacency list over here, back down. We're also going to indicate false, since we have not visited anything. Then we're going to initialize a queue with integer and another queue right here. Then we will indicate what has been visited at a specific vertex to indicate that this is true, and then we're going to push our vertex inside of the queue to indicate that it has been visited. Then we're going to call upon our helper function inside of our actual function, then put it in queue, and then also visited from here. Then finally output all the way to the end of our adjacency list. Now, we're going to do the exact same thing we did for depth first search, except for we're going to do this for breadth first search. So BFS recursive starting at vertex 0. That means in particular we will have breadth first search recursive at the very start, and this time we're going to have 0 in that case. Let's build and make sure everything's already lined up. Build succeeded. Let's run this, and we get our expected output that we need for breadth first search as well. Now all we did was just implement a different method for how we actually built out breadth first search.
using principles of recursion, unlike our iterative approach where we just use the queue and checked whether each vertex would be called upon whenever we visit it and push it inside of our queue with their respective weighted edge as well. So we know exactly in particular over what is being added inside of our queue and then finally outputting our following edges as well. Now let's go over a brief overview for what we have already accomplished for our weighted graph.
Hey everyone, thank you very much for taking time to watch this. If you found this video helpful, be sure and feel free to please like and subscribe. And if you do have any other questions or suggestions, please put them in the comment section. And as always, take care. Cheers. Bye-bye.